When you think about the California energy crisis of 2000, one name probably jumps to mind: Enron. It's become this classic story of corporate greed. But what if that story, the one we all think we know, completely misses the real villain? Today, we're diving into failure by design to see how this wasn't just a story of corruption. It was a catastrophic failure baked right into the system's own blueprint. Okay, let's set the scene. Imagine you're in a control room back in the year 2000. It's all high tech, screens everywhere, blinking lights, but the feeling in the air isn't excitement. It's pure, raw panic. You have operators just scrambling, trying to keep an electric grid that serves millions of people from completely crashing and burning. You can just feel the sheer desperation in this quote from Ed Riley, one of the grid operators. This wasn't some abstract problem on a spreadsheet. These were real people on the front lines, making these frantic calls, trying to find just 1 megawatt of power anywhere to keep the lights on, and coming up with nothing. And the fallout? It was absolutely immense. The entire state was hit with rolling blackouts. Its biggest utility companies were pushed to the very brink of bankruptcy. When all the dust settled, it went down as one of the worst financial disasters in American history. And the craziest part? It was all caused by the very system designed to stop this from ever happening. So who do you blame for a mess like that? Well, the public narrative, as you can see on the left, it settled pretty quickly on corporate greed, with Enron as the poster child, and a lot of political meddling. And yeah, those were definitely factors. But this explainer is focused on the hidden suspect, the core argument from our source material, the market's own blueprint. The problem wasn't just a few bad apples, the whole barrel was rotten from the start. So how could this possibly happen? Well, to get how it all went so wrong, you first have to understand the incredibly ambitious, powerful idea that started it all: the concept of market design. This wasn't just about letting the market run free. It was about trying to engineer a perfect market from scratch. Market design is a really fascinating field. Think of it this way. Instead of just letting a market pop up on its own, the designers treat it almost like a computer program. They build it as this complex algorithm, a kind of economic machine that's supposed to spit out the perfect, most efficient outcome every single time. It's a market built by committee. And you can totally see why this is so popular. I mean, market design has had some incredible successes. It's the secret sauce behind matching medical students to the right hospitals, getting kids into public schools. Heck, it's what powers the platforms we use every day, from Uber to Amazon. It's a seriously powerful tool. But, and this is the crucial point, there's a catch. When you go from a neat, tidy problem like matching doctors to something as sprawling and complex as a public good, like electricity, something that involves massive physical infrastructure, the track record gets a lot messier. And when these systems break, the experts don't just blame bad actors, they point to design flaws. So let's get back to California and take a closer look at those cracks. We're going to use this idea of market design as our lens to see not just what went wrong, but why. The very structure of the market made a disaster like this almost inevitable. The core finding here is just startling. The system wasn't just weak against bad actors, it actively created them. It was, and I'm quoting here, riddled with incentives and opportunities for destructive behavior. The design didn't just allow people to game the system, it basically rolled out the red carpet and encouraged them to do it. Okay, so what were these flaws? The first big one is called differential simplification. To make the market model work, the designers had to simplify the insane complexity of the real-world power grid. But, and this is the key, they simplified different parts of the market in different ways. This created all these weird inconsistencies, and smart traders quickly figured out how to exploit the gaps between these two different simplified worlds. The attempt to simplify actually made it more complex. The second major flaw was what they call porous boundaries. Think of the market as a series of connected but separate rooms. Well, the walls between those rooms weren't solid. They were full of holes and weak spots that let traders link different parts of the market together in ways the designers never, ever intended. This created huge, profitable loopholes that completely destabilized the grid. So you have to be wondering, why were these giant, gaping flaws built into the system in the first place? Well, to answer that, we have to look at how the market was actually put together. And that brings us to what the source calls the modularity trap. Now, modularization is a pretty standard and usually very smart way to build something super complex on a tight deadline. You take the big, scary project and you break it down into smaller, bite-sized modules. Then you give each module to a different team, and they can all work at the same time. Frankly, it was the only way they could have built this thing so fast. This slide gives you a pretty good idea of how that worked. You've got one team working on, say, the day of market, and a couple other teams working on different pieces of the imbalance market. Each team is just completely focused on their own little box, their own piece of the puzzle, trying to make it perfect all by itself. And right here, this is the trap. On the left, you see the promise. It's fast, it's independent, but the peril on the right is what brought the whole system crashing down. A totally rational, smart fix that one team made inside their own little module could accidentally create a massive, unforeseen loophole when it connected with another team's module. Because nobody could see the whole picture, they were unintentionally building a system that was full of contradictions, just waiting to be exploited. So, what's the final verdict? What's the fundamental lesson we're supposed to take away from this completely man-made catastrophe? Not just for energy markets, but for any time we try to engineer these huge, complex systems. The author delivers a really sobering conclusion. For these massive, complex problems, trying to engineer a perfect market, he says, conjures the worst of both worlds. That is an incredibly bleak and powerful statement. And what are those two worlds? Well, first, you have the raw self-interest of market players, which you kind of expect. But then you smash that together with all the blind spots, the communication gaps, and the coordination problems you find in any giant organization. And that combination, that toxic mix, creates a system that is uniquely fragile and just primed for a spectacular failure. Which leaves us with a really critical question for today, as we try to design systems to solve everything from climate change to healthcare. When we apply this kind of complicated engineering to our most essential services, are we really building a better, more efficient system? Or are we just designing a more sophisticated, more complex, and ultimately a much more dangerous way to fail?